Let me introduce you all to Chintu here. Chintu is a very big fan of oranges. One day he was eating orange and he was playing with the outside peel, the outer covering of the orange. And suddenly some liquid went into his eyes and it started burning. He couldn't control the burning. So he ran to the sink and he splashed water. He was washing his eyes with water. And when he washed his eyes with water, the burning stopped and he did not feel anything. He put more water, he is feeling nothing. Then what he did, okay, he decided to wash his face. He takes the soap and he tries washing the face. The soap is very soapy. It's like the liquid is very sticky and soapy. There is foam formed and everything. He was wondering why this is happening. Like all three ones are giving three different things. So the first one, why the orange peel gave him burning sensation is because this orange peel is a acid. So when acid entered his eyes, it gave him very burning sensation. Then he wanted to remove that burning sensation. So he splashed water, which is neutral. So this neutral liquid, there is nothing. He felt nothing. Then he wanted to wash his face. He touched the soap. The soap was very soapy, sticky in nature. That was base. Hello everyone, welcome to pyqs. I am Yashaswini and today we are going to learn about acid bases and salts. In this video, we will be covering the whole acid bases and salts chapter and we will be understanding what are acids, what are bases, how they are useful and how many acids and bases are there in our everyday life. Then we will see how to differentiate these acids and bases, what are the major indicators, what is their importance and how they were found, how we can find some indicators in our real life. Then after that, these acids and bases, they are going to react. No, they are going to react with different metals, non-metals. So we will see some reactions of acids and bases. And finally, we will see some salts there are 5 major salts that we will be covering, how they are prepared, what are their major applications. With all these understanding, we will solve some previous year question papers from acid bases and salts. So let's move on. What do we see on a screen? We see that there is a periodic table. We have already studied periodic table. So in a periodic table, what do we observe? The first thing here, this red colored elements, they are called as metals, and the green and blue colored elements, we call them as non-metals. So we know metals, we know non-metals. Now these metals and non-metals are any element, they have fixed number of electrons. We have already studied this. When they have fixed number of electrons, they are like settled. But sometimes they don't want to settle. They are very acting, they are very overexcited, they are playful. So that time they lose an electron or gain an electron. So whenever a metal loses an electron, we call them as cations. So when a metal loses an electron, we call them as cations. The same way, even some non-metals don't lose an electron but take on extra electron. They snatch some extra electron. So when they take electron, we call them as anions. So what are cations? Cations are the ones which will lose an electron. Anions are the ones which will take electron. Now cations. Let's take some examples. I told metals will form cations. What are the examples? Let's say I had sodium. Sodium is a metal. This sodium, when it loses one electron, it will become a cation. So it is losing. Whoever is giving, if you give money to some other people, you are the more greater person. So we will add a plus sign here for sodium. This represents cation. When the sodium is giving one electron, somebody else should take it. So one of the non-metals will take it. Let's say we'll take chlorine here. Chlorine is one non-metal. So chlorine is taking electron. He is begging and snatching that electron. So we will represent him with a negative sign. So sodium is an example of a cation, chlorine is an example of anion, Cl minus. Now because he gave electron, chlorine took electron, these two are going to combine to form a compound NaCl, sodium chloride. So in any compound there will be one cation, one anion. Cation is the one who is giving electron and anion is the one who is taking electron. So we are clear about cations and anions. Next, these metals, they are always there. These metals, they react with oxygen. So when these metals react with oxygen, say I had a metal like sodium only, I'll take sodium. The sodium reacted with oxygen. What will it form? It will form Na2O, sodium oxide. So all the oxides formed by metals, we call them as metallic oxides. And similarly, like how metals are reacting with oxygen, non-metals also react with oxygen. Say we'll take sulfur. Sulfur is a non-metal here. Sulfur reacts with oxygen. When sulfur reacts with oxygen, we are getting sulfur dioxide. Sulfur dioxide, it is a non-metal forming an oxide. We call this as non-metallic oxide. So what are metallic oxides? Metallic oxides are the oxides formed by metals. Non-metallic oxides are the oxides formed by non-metals. So what all did we study here? We studied what are cations, anions, and we studied what are metallic and non-metallic oxides. Okay, ma'am, I am clear on this. What next? Here, in the last video or in the last chapter, if you have studied carefully, we saw that for water, I am passing, if I pass electricity, I am getting hydrogen and oxygen gas. We all have studied this reaction, that is H2O when passed with electricity will give H2 gas plus O2 gas. But originally or in the laboratory, how is this reaction happening is, there will be one tub with all the current passing equipment, and what will happen, it will be filled with water. So water is already present. When the current passes through water, what will happen is, this H2O will split up as H plus and OH minus ions, because when electricity is passed, they have to carry that current, that electricity should be passed on. That's why they are forming H plus and OH minus ions. So any compound that is capable of giving H plus ions, we call them as acids. And any compound that is capable of giving OH minus ions, we call them as bases. And since water is capable of giving both H plus and OH minus ions equally, we call it neutral. So till here we understood there are three types of liquids: acids, bases and neutral liquids. Acids are the ones which will give H plus ions, and also they are burning. Remember Chintu's eyes were burning when acid entered, so they will cause burning sensation. The second type of liquid is bases. What are bases? They are the ones which will give OH minus ions, and when they give, these OH minus ions, they will react with other to form compounds. So bases are very soapy in nature. And the third type is neutral. Neutral is like water. So it will give both H plus and OH ions equally, and they will not make you feel anything. They are just black. So if we have understood everything here, let's take a little content quiz on the same. So there are 3 points. Let's see who scores the maximum amount of points. The first question is, name the cation and anion in zinc sulfide. There is zinc here and sulfur here. So what is zinc? Zinc is a metal. So the metal is going to form a cation. And we know that non-metals are the ones which will form anion. So here sulfur is the non-metal, so it will form anion. So the cation is zinc and the anion is sulfur. Now, is sulfur oxide a metallic or a non-metallic oxide? Sulfur oxide, sulfur is a non-metal, so it is going to form a non-metallic oxide. Next, what is the difference between an acid and a base with respect to the ion they contribute? We studied that in the previous slide. Acids, when they react, what are they giving? They are giving H plus ions. And bases, when they react, what will they give? They will give OH minus ions. So the ion differentiation is acids give H plus ions and bases give OH minus ions. So with this, we have understood the basics that is required for this chapter, and now we will study more about acids and bases. Now let's see how to differentiate acids and bases. In the previous slide, we saw that acids are the ones which will give away H plus ions and bases are the ones which will give OH minus ions. So this column is for acids, this column is for bases. Now in the first case, when Chintu was playing with orange, it gave him some burning sensation and we call that liquid as acid. So acids are the ones which will give burning sensation, or you can call them, they are very corrosive in nature. So corrosive meaning like I put my hand inside acid, what will happen, my whole hand will start burning and it will like be corroded, it will be destroyed completely. But in case of base, what we saw there was soap, it is very soapy in nature. So bases are soapy in nature. That means what, ma'am? Bases are not harmful. No, bases are also harmful. If too much amount of bases, there are very some like very if you have like keep your hand inside a basic solution, your hand will start melting. So acids will give you burning sensation and they're very corrosive. Bases are soapy in nature and they will cause melting. Now we saw about their nature. Now let's say it's like somebody tasted acid. What is the taste they get? They will get sour taste or katta taste. When they tasted base, they got a very bitter taste or kadwa taste. So we understood the three differences between acids and bases. So let's take some examples. So some of the examples of acids are HCl, hydrochloric acid, H2SO4, sulfuric acid. The orange we saw, no, that orange has citric acid. So one more thing, if for bases also we'll write off some examples here. Say NaOH, sodium hydroxide is a base, KOH, potassium hydroxide, pyridine. Here are some of the examples of bases. Now, if you closely observe these HCl, H2SO4, when they react, they will give more number of H plus ions, whereas citric acid will give less number of H plus ions. So, based on how much amount of H plus ions they give, we can classify them as strong acids and weak acids. If they are giving more number of H plus ions, we call them strong acid, and if they are giving less number of H plus ion, we call them weak acid. Similarly for base, let's say in base, what are base giving? They are giving OH minus ions. So when the base is giving too many number of OH minus ions, we call them as strong base. And when they give less number of OH minus ion, we call them as weak base. So examples of strong base are NaOH and KOH, weak base is pyridine. So now we have cleared about what are strong bases, weak bases, and the three major differences between acids and base. So here we classified acids and bases as strong and weak. Ma'am, is that the only classification? No. Where are acids present? Where all we have acids? Acids are present everywhere. Like say for example citric acid, it was present naturally. But we can't always have naturally present acids. Say for example HCl, H2SO4, they are not naturally present. Those HCl and H2SO4 we have to manufacture. So based on how they are present, we can classify them into organic and mineral. So organic ones are the ones that are naturally present, mineral are the ones that we manufacture. And here see, citric acid is an organic acid. So most of the organic, like almost all organic acids are very weak in nature. They are weak acids. Mineral acids we manufacture like HCl, H2SO4, they are very strong acids. Now, exactly similar to how we classified acids, we will even classify bases. Let me take a different color. Say bases. Again, they are classified as organic and mineral. Now, organic bases, just like organic acids, even organic bases are very weak. Say pyridine. Pyridine is an organic base. Why? It is present naturally. So this is very weak base. Mineral bases, we manufacture them like NaOH, KOH, they are all mineral bases. We are manufacturing them, therefore they are very strong. So we saw how acids and bases can be classified as strong acid, strong base, or weak acid, weak base, and we saw how to what are the major differences between acids and bases. Now, ma'am, you told that the difference between an acid and base in taste is acid is sour, base is bitter. Can we taste all the liquids? Taste, oh, this is very sour, this is an acid, this is very bitter, this is a base. Can we do that? No, we cannot do that. That is why we will use some more chemicals to identify if it is an acid or base. So let's study about those chemicals. So those chemicals that will help us identify what is an acid or which is an acid, which is a base, we call them as indicators. So I am telling indicators are chemicals. What are they? Let's say I have one solution here and I took one more chemical and I added here. So initially the color of the solution was blue. I added a pink color, another solution to it. Now after some time, if I observe, this blue color would have become say purple. The color of the whole solution changed because of addition of this one chemical compound. And if it was, let's say the solution was acid, the color got changed. If it was a base, the color would have remained the same. So indicators are chemical substances which when added to acid or base, they will undergo some chemical, they will show color change or their smell will change, due to which we can identify it as an acid or a base. So we understood what are indicators. Now let's see what are the different indicators that are present everywhere. So in indicators, there are three major types of indicators. The first type of indicators are natural indicators. So natural indicators are the indicators that are present naturally, like in the world it is present naturally. We don't have to manufacture them. The first type in natural indicators are litmus. Litmus is a chemical compound. It is obtained from lichens. If you have heard what lichens are like some small tiny organisms. From them this litmus is obtained. So from litmus, I have litmus solution now. I am adding it to from litmus solution I made paper. That paper is blue in color. This blue color paper I dip it inside acid. When I dip a blue color paper inside acid, it will turn red. When blue turns red, we can confirm that it is an acid. Now, if I take the red litmus paper and keep it inside a base, the red litmus paper will turn blue. So when the red litmus turns blue, we can say it is a base. So what will happen if I take red litmus paper and keep it in acid? There will be no change. The red will remain the red. If I take blue litmus paper and keep it in base, it will remain the same. But when I take blue litmus, keep it in acid, it will turn red, and red litmus will turn blue in case of base. Now that we studied litmus, which is naturally available. One more example of an indicator that is naturally available is turmeric. We have turmeric powder. Turmeric powder, if you add it to base, there is nothing happening, no change. When turmeric powder was added to acid, no change, nothing happened. But the same turmeric powder, when we add it to a base solution, it turned red. We all know, no, turmeric is yellow in color. So in basic medium, the yellow color became red color. So whenever, if turmeric turned red, we could call it as basic solution. Now these are natural indicators. Now we'll take synthetic indicators. The second type of indicators is synthetic indicators. So synthetic indicators are man-made or artificial indicators. The first example is methyl orange. When you see a methyl orange solution, it will be in orange color. But the same methyl orange solution, when added to an acid, will give you red color. So orange became red. So we can conclude that an acid is present. But if the same methyl orange is added to a base, we will get yellow color. So if we are getting yellow color, we can conclude that it is a basic solution. The second type of the second example of a synthetic indicator is phenolphthalein. Of normal phenolphthalein solution, if you see, it will be purple, magenta color. But when you add this magenta color solution into an acid, there will be no change. Like no change at all. But the same solution, when we add it to a base, it will become pink. Remember, phenolphthalein was purple or magenta, purple color, dark purple color. The dark purple color became pink. That will conclude that it is a base. These are some of the examples of synthetic indicators. Now the last type of indicators are called olfactories. What is this olfactories? The word is a little new, no? So olfactories, the word olfactory means evolution of smell or the sense of smell. So olfactory are chemicals that will change the smell for when they are in acid or base. So some of the examples are onion, vanilla. So onion, vanilla, when they are in very strong acid, like onion has some smell, no, we'll see, oh, it is onion only, onion is only, this is the smell of onion cutting. Or vanilla ice cream is very delicious, we will get, oh, vanilla ice cream is coming. So when they are in strong acidic medium, they will give a lot of smell, strong smell. But the same onion and vanilla, if you keep it in a basic medium, you will not get any smell or it is no smell. So through the smell, we can differentiate it as an acid or base. So here we understood how to differentiate between an acid and base using different indicators. Now let's see some of the reactions. Acids react with three main chemical compounds. Let's take the first one. Acid reacts with metal. So when acid reacts with metal, we will get a salt and hydrogen gas. So let's take an example here. Zinc, it is a solid metal. It is reacting with HCl, which is a liquid, to give zinc chloride. Zinc chloride is a salt and hydrogen gas is evolved. If you closely observe this reaction happening, when zinc is added with HCl, we will see small bubbles evolving. Those bubbles, gas bubbles that is evolving, you can also name it as effervescence. These gas bubbles, when we bring a burning candle near the gas that is evolved, we will hear a pop sound. That pop sound confirms that hydrogen gas is evolved. Pop sound is a confirmation that hydrogen gas is being evolved. This is the first type of reaction. The second reaction, when a metal carbonate or a bicarbonate, metal carbonate is like Na2CO3, ZnCO3. Bicarbonate means like there is a hydrogen atom attached with CO3. Say for example NaHCO3 or Zn2HCO3. Sorry, that is not. Let's take one more example there. Let's take lithium bicarbonate, LiHCO3. So these are metal carbonates and bicarbonates. When a metal carbonated is CO3, so it is reacting with acid, a salt, and carbon dioxide gas is evolved. So let's take an example. Na2CO3 reacts with HCl, hydrochloric acid. It will form NaCl, common salt that we know, sodium chloride, with CO2, carbon dioxide gas, and water. The carbon dioxide gas, sorry, here there is a mistake. Water is a liquid. So carbon dioxide gas that is evolved. How do we know carbon dioxide gas is evolved? We will pass this carbon dioxide gas through lime water. When we pass this gas through lime water, the lime water turns milky, which confirms that carbon dioxide gas is only evolved. So lime water turns milky. Now the third type of reaction is when a metal oxide reacts with acid, we will get salt and water. This is a simple displacement reaction where zinc oxide is reacting with HCl, we will get zinc chloride and water. This solution is formed. So these are the three reactions, these are the three types of reactions on how acid reacts with different compounds. Now let's take the same for base. So when a base reacts with a metal, say the first type of reaction for bases is bases reacting with metal. When a base reacts with a metal, we will get a salt. So example here, zinc reacts with NaOH, we will get Na2ZnO2, sodium zinc oxide plus hydrogen gas. How do we confirm hydrogen gas is evolved? This gas, we will bring a burning candle, we will get pop sound. When a burning candle is brought near the gas that is evolved, we will get a pop sound. That confirms hydrogen gas is evolved. Now the second type of reaction is when a non-metal oxide, we have seen non-metal oxides, sulfur oxide, carbon dioxide, they are all non-metals forming oxide. So when a non-metal oxide reacts with a base, we will get salt and water. Example, carbon dioxide reacts with NaOH. NaOH is a base. We will get Na2CO3, sodium carbonate with water. This reaction is the second type of reaction. Now, if you see, I have not written the carbonate or the bicarbonate reacting with base. In the previous case, in acids, we had the reaction. In base, it is not there. Are you wondering why? Yes, because carbonates and bicarbonates are already basic in nature. A base and a base cannot react, no? It should be opposite only when they react. So, both are basic, that's why they are not going to react. These are some of the reactions of bases with different chemical compounds. We also saw acids. Now let's solve some previous year questions on the same. This question was asked in 2012 for 3 marker. These kind of questions are your most expected questions and they're really important, because though you might know the reaction, you might write the reaction, if you don't answer each and every part of the question, you will not be getting full mark. So what is the question? The question says zinc sulfuric acid H2SO4 is added. We have taken 5. They have taken 5 ml of sulfuric acid and added to zinc granules. So what is happening? There is a test tube. There is zinc granules here, and sulfuric acid is added. So what is the reaction? We have already seen the reaction. Zinc reacts with H2SO4. We will get a salt ZnSO4 plus hydrogen gas. So here also, when acid is added to zinc, we are going to get effervescence, that is hydrogen bubbles. These hydrogen bubbles are going to evolve. So what do we observe on the surface of zinc granules? We are going to observe effervescence. We are going to observe effervescence or hydrogen gas bubbles are formed. That is the answer to the first question. The second part of the question. What do you observe when the gas being evolved is passed through soap solution? Let's say I pass this through a soap solution. So what will happen? Soap solution already has bubbles. So when gas is formed, this gas will get absorbed inside the soap bubble. Say I had soap bubbles like this. This gas will go and get filled inside the soap bubble. So what do we observe? We observe that the hydrogen gas gets captured inside the soap bubbles and those soap bubbles start evolving, or more soap bubbles are formed which are filled with hydrogen gas. This is the answer you write for the second question. So here you will write hydrogen gas filled soap bubbles are evolved. What do you observe when a burning candle is brought near the gas-filled bubble? Now we saw that these bubbles are raising up. Now I am bringing a burning candle near it. I have a burning candle like this and there are bubbles coming here. So what will happen? These burning candle will extinguish the burning candle. So the fire will be gone and we will hear pop sound. So you have to write the gas will extinguish the burning candle or put off the fire and we will hear a pop sound. That should be the pop sound and fire put off. These are the two important words you have to mention in part C. For you, if you want full marks, you have to mention those two words for what you observe when gas-filled bubble is passed through a burning candle. Now, is the observation same with different acids? Say, here zinc was added with H2SO4. Instead of H2SO4, we could add HCl, HNO3, all other acids. So we saw previously also, whenever a metal reacts with an acid, it is going to produce hydrogen gas. So this observation is same with all different acids. You can write, yes, the observation is same with different acids. If you write all the 4 points along with a balanced reaction, this reaction is not balanced and the states are not written. If you write the states and balance the reaction, then you will be getting full 3 marks. So, are we clear on this question? Hoping that this question is clear, we will solve one more question. The second question here is, this was a question that was asked in 2008 for 2 marks. A student dropped a few pieces of marble in HCl. What is marble? Marble is a common name. There is a chemical name for marble. The marble is CaCO3, calcium carbonate solid. This marble is added with dilute HCl. So, HCl acid. So, what is the reaction? This is a metal carbonate. It is reacting with acid. So, we will get a salt, calcium chloride salt plus carbon dioxide gas plus H2O. Make sure you write the states and balance it. Okay. Is the reaction balanced? Just have a quick look. H2HCl. The reaction is balanced. So, when the marble is added with HCl, this is the reaction that is going to happen. They are asking you the gas that is evolved. The gas that is evolved is passed through lime water. So, what do you observe? We saw in the reaction when carbon dioxide is passed through lime water, the lime water turns milky. The word milky must be present. The lime water is a clear solution. When carbon dioxide gas is passed through, it will turn milky. That is the observation you make, and you have to write a balanced chemical equation for the same, which you have already written. If you make sure you are writing both the sentences, one is the balanced chemical reaction and the second is lime water turns milky, you will get 2 complete marks. With this, we have understood how acids and bases react with different chemicals. Now, let's understand more about indicators. Now that we have seen different reactions of acids and base, what will happen if an acid mixes with a base? So we'll see that here. When an acid mixes with a base, it will form a salt and water. This reaction is called neutralization reaction. Let's take an example. Let's say I have HCl acid. HCl is hydrochloric acid. It reacts with NaOH, sodium hydroxide. Then it will give a salt, NaCl, salt and water. We all know that both acid and bases are very dangerous in nature. So when they are mixed together, they will produce a lot of amount of heat, and hence this neutralization reaction is a very highly exothermic reaction. If you closely observe here, Cl and Na are combining to form the salt, and H and OH are combining to form the water molecule. In one of our first slides, we saw that water is the one which will give equal amount of H plus ions and OH minus ions. Also, if you closely observe, I have written HCl aqueous here. Even in the previous reactions and all, either HCl is aqueous or even the base is in aqueous nature. This is because if it is a pure acid or a pure base, like pure acid, like just HCl, I have just HCl or just NaOH, they will not react. They will not produce the H plus or the OH minus, due to which they will not react. So for example, like HCl, I have just pure HCl, it will not react. When this HCl has some amount of water content, this water is only releasing H plus, so it will make HCl also release more H plus, due to which they will react. So based on the amount of water content in an acid or a base, we can call them there are two types of acids or base, which is concentrated acid or dilute acid. So what is concentrated acid or dilute acid? See, if there is more amount of acid and less amount of water, we call it as concentrated acid, because it will produce more amount of H plus ions. When there is less amount of acid or base and more amount of water, we call it as dilute acid or dilute base. So we are now clear about what will happen when an acid reacts with a base. So we understood acid bases, they are concentrated, diluted. We have to also have a value to identify a strong acid or a weak acid, or this acid is concentrated or this is diluted base. We need one value to identify, no? For that value, we will learn about pH scale. So pH scale is a number line. Well, let's consider this as a number line. It has all the values from 0 to 14. Now, what does pH scale do? It will consider the amount of H plus you produce. Say for example, acids, they will produce H plus ions, no? So based on the number of H plus ions you produce, they have devised a scale which will depict the amount of acidity or basicity. So what they did, they took water. Water is neutral, it will produce equal amount of H plus and equal amount of OH minus. That is why they marked water as neutral, or any neutral liquid as the pH of 7. So pH 7 means it is neutral. So now if pH 7 is neutral, if I am producing more amount of H plus ions, I am far away from neutral. I have to be far away. So whenever I am far away from neutral, we are acidic in nature. So all the values less than 7 are acidic. If like I am very far, like 0 or 1, my pH value is 0 or 1, I am strong acid. Again, if I am far away from neutral, I am towards, like I am producing more amount of OH minus ions. So I will be producing very less amount of H plus ions. Then I will be basic in nature. Now, as I told, even the bases should have some amount of water content. When base is mixed with water, we can also call them as alkalis. So alkaline nature will be from after 7. If the value of pH is above 7, we will call them alkaline. And if it is very strong, like 14 or 13, we will call them strong base. and anything that is very close to the neutral one will be weak base or weak acid. So we understood what is pH scale and how we can identify a strong acid, weak acid from pH scale. But like, it is important in chemistry. Why is it important in daily life? We all have heard about acid rain. There is, like, due to pollution, there is acid rain happening there, here, and it is very dangerous to aquatic life. We have heard this news a lot of times. What is happening in acid rain is, so like water, the rainwater will have some chemicals which are acidic in nature. Its pH will be less than 5. So rainwater which has pH less than 5, we call it as acid rain. This acid rain will mix with the river water or the sea water. Sea water, river water, it should be neutral. It is like pH 7. Now when this rainwater less than 5 mixes there, the acidity or the pH of the river water will become less. It will also become acidic in nature, due to which the fishes or the aquatic life in the river or the sea, it is very difficult for them to survive. Now same way, let's take one more example where pH is important. In our digestive system, we have HCl acid. HCl is important for digestion. This HCl acid has a pH of 1. pH of HCl acid in our digestive system. So the digestive HCl has a pH of 1 to 2. It varies between 1 to 2. If without taking care, if the pH of this HCl has varied, it has become more or it has become less, what do? We take some chemicals, like we drink Eno or we'll take Gelocil. These Gelocil and Eno are nothing but bases. They are pH of 10 to 11. They are called as antacids. They will make sure that the pH of HCl will return to normal, so that we will not have any health issues. So pH is very important even in our daily life. Now that we have understood pH scale, let's solve a few questions. The first question here is, it was asked in 2010 for 2 marks. So what they have given in the question, they have given 5 solutions, A, B, C, D, E. These 5 solutions were tested and their pH values were identified. The pH value were 4, 1, 11, 7 and 9. Now they have, based on this sentence, they have asked a few other questions. So before we go ahead reading the question, first what you do is see the pH values and arrange the pH value in ascending order, that is smaller to lower. What is the lowest value given? 1. Then we have 4, then we have 7, 9, 11. So these are the 5 solutions. 1 is representing the solution B, 4 is representing the solution A, 7 is representing solution D, 9 represents E and 11 represents C. So remember, from the last side, like pH scale, the one which is onto the leftmost side where the value is 0 or 1, it is more acidic in nature. 1 to the right is more basic. Same rule applies here also. The one to the left hand side, or which has a least value, is more acidic in nature. To the right hand side is more basic in nature. So the first question is, name which solution is neutral. So neutral means the pH should be 7. So the solution which is neutral here is D. So answer for A is D. Which solution is strongly alkaline? Alkaline means it is more basic in nature. It should be far away from the neutral towards the right side. The right side which is farthest away is C. So answer to the question B, that is strongly alkaline solution, is C is a very strongly alkaline solution. Next, strongly acidic solution. Acidic means it should be to the leftmost side of the pH scale. Here B is the solution which is to the leftmost side. Therefore, for B, that is strongly acidic, it should be B. And last question is, arrange the solution in increasing order of pH. We have already arranged it in the increasing order of pH. So if you write all this in one answer, you will get complete 2 marks. So now we have cleared about pH. Let's move forward. Now that we have understood what are acids, what are bases, how they react, let's move on to salts. We saw in one of the slides that acid, when it reacts with a base, it is getting salt. So now we will see more about salts. In salts, we are going to study about their preparation and application of four major types of salt. The first variety of salt that we are going to study is NaOH, sodium hydroxide. The second, sodium hydroxide is also known as caustic soda. The second salt that we will see is CaOCl2. Calcium oxychloride, or also commonly known as bleaching powder. The third type of salt is Na2CO3, sodium carbonate. Sodium carbonate is also known as washing soda. The fourth type of salt is NaHCO3, sodium bicarbonate, also known as baking soda. So now, when you hear the word salt, what is the first salt that you remember? What is the first common thing that you remember? The salt we will be using in our household for our food everywhere. That salt that we use in our household, in our everyday life, is NaCl, or common salt, sodium chloride or common salt. Apart from being used in everyday life, this sodium chloride has a lot of industrial applications because it can be used to prepare many other salt. So let's see what are the other salts that I can prepare from NaCl. The first salt that I can prepare from NaCl is NaOH, sodium hydroxide or caustic soda. So let's see how sodium hydroxide is prepared. So let me take a bath containing NaCl solution. So I have one tub, it has NaCl solution. NaCl solution is also known as brine solution. Now for this solution, I am passing electricity. I am keeping two cathode, one anode, and I am passing electricity. So when I pass electricity to a solution of NaCl, NaCl solution has NaCl and H2O. So I will get Na plus cation, Cl minus anion, H plus cation, and OH minus anion. So when electricity is passed, this H plus will go to cathode and will evolve as H2 gas. And chlorine, Cl minus anion, will go to anode and will get evolved as chlorine gas, Cl2 gas. The remaining two ions, NaOH and OH minus, will combine together to form NaOH. So the reaction is NaCl plus H2O. We will get NaOH plus H2 gas plus Cl2 gas. So by this method, we are producing NaOH or caustic soda, and this process of producing NaOH is called chlor-alkali process or electrolysis of brine solution. Both the names you can call. So we understood NaOH is prepared this way. Now if you closely observe here, Cl2 gas is being evolved. This Cl2 gas is like very important. I'm just evolving it. So what I will do, I will react Cl2 gas with calcium hydroxide. Slaked lime. Calcium hydroxide. The common name of calcium hydroxide is slaked lime. Slaked lime, when it reacts with Cl2, I will get CaOCl2. CaOCl2 plus we will get the byproducts. So this CaOCl2 is also known as bleaching powder. Bleaching powder, it is a very common name, we all have heard. Calcium oxychloride. Bleaching powder is used to remove hard stains, or if a place is very dirty, we can apply bleaching powder and it will get cleaned off. Or we are getting very bad smell, we will apply bleaching powder so that the smell is not that bad. Or bleaching powder also has the capacity to kill all the germs. So it is used in water purification. One of the major applications of bleaching powder is in water purification. So now we saw bleaching powder. So we saw two types of salt being prepared from one major salt, that is NaCl. Next, what will I do? I will take NaCl. I will react this NaCl with water, CO2 and ammonia, NH3. When I react NaCl with all these three compounds, I will get NaHCO3, sodium bicarbonate, and NH4Cl, ammonium chloride. This sodium bicarbonate, NaHCO3 that is formed, is also called as baking soda. Baking soda, again, we have heard this very often in our kitchen. Why? While preparing cake or while preparing bread, we will add a little bit, like just one pinch of baking soda, so that the cake becomes very fluffy and very soft. So baking soda or NaHCO3 is responsible for giving that fluffiness. So we saw three types of salt. Next, what I will do is, I will take this baking soda, NaHCO3, and I will heat it. Say NaHCO3 I am heating this NaHCO3. I will get Na2CO3 plus H2O plus CO2. NaHCO3 is giving me Na2CO3 and H2O and CO2. We are worried only with Na2CO3. This sodium carbonate is also known as washing soda. Washing soda again is very much important because it has a lot of application in textile industry, paper industry. This also has the capacity to remove hardness from water, like the permanent hardness, no? The permanent hardness can be removed by washing soda. This washing soda, Na2CO3, when we keep it open, no, it will absorb water molecules from the surrounding and will form Na2CO3 dot 10H2O. So sodium carbonate alone will only be called as sodium carbonate, but sodium carbonate with this 10 water molecules will call it as washing soda. This 10 water molecules, they are not attached to the molecule. So with simple amount of heating, the water will evaporate and we will get only sodium carbonate. So this water molecule that is attached is called water of precipitation. Now, sodium carbonate is not the only salt that has water of precipitation. There are many other salts. One of the other important salt, or the fifth type of salt that we will be studying now, is calcium sulfate or gypsum salt. Calcium sulfate will have two water molecules with it, 2H2O. This is gypsum salt. Now, when I take this gypsum salt and heat it at 373 Kelvin, the temperature should be 373 Kelvin, I will get calcium sulfate dot half H2O plus 1.5 H2O is evaporated. This calcium sulfate with half H2O is a very important salt, or very important salt, because it will form very hard substance. This hard substance can be used for covering the fractured bone in hospitals. Like your bone is fractured, if you go to the hospital, they will put a cast on you, no? That cast is made up of this calcium sulfate dot half H2O, which is also known as plaster of Paris. It is a hard substance. Plaster of Paris can also be used for patching a broken wall and in also paint industry. So now we have understood 5 different types of salts, how they are prepared, what are their major applications. Let's solve some questions on the same. Let's solve this question now. What is the question? The question says there is an industrial process for manufacture of caustic soda. What is caustic soda? NaOH. So this is a process of manufacturing of NaOH. Now, how is NaOH manufactured? We have already seen. NaOH is manufactured via electrolysis of brine solution. So, it involves electrolysis of an aqueous compound. What is the aqueous compound? Brine solution. So, what is the formula of brine solution? Brine solution. The formula is NaCl aqueous. So, it is an aqueous solution of compound X. The compound is NaCl. In this process, two gases Y and Z are liberated at cathode and anode. Let's have a quick revision of electrolysis. So what is happening? We have a bath, we have NaCl solution. Then I will place cathode and anode and I will pass electricity. Sorry. Since there is NaCl solution, Na plus ion, Cl minus ion, H plus ion and OH minus ions are formed. 4 ions are formed. This H plus cation will come to cathode. H plus ion will come to cathode and will get evolved as hydrogen gas. So the gas that is evolved at cathode is H2 gas. Cl minus is another anion. Cl minus will come near anode and will evolve as Cl2 gas. Cl2 gas. So the second gas that is liberated at the anode is chlorine gas. So this we are clear. So we have found the two gases has hydrogen and chlorine. Now they are telling that the chlorine gas, that is Z, on treatment with slake lime. What is slake lime? CaOH twice. So, chlorine gas Cl2 on treatment with calcium hydroxide, slake lime, we are going to get a major product CaOCl2 or the bleaching powder, calcium oxychloride forms the compound B, which is calcium oxychloride. So first, like this is a 3 marker. So this 3 marker will require you to write all the 4 names. X is NaCl solution or NaCl, Y is hydrogen gas, Z is chlorine gas, and B is calcium oxychloride. You should also write the reaction of chlorine reacting with slake lime to give calcium oxychloride. If you have time and you want to impress teacher, also write the electrolysis reaction. It will be an added advantage. So we solved this question. Let's see another question. The second question here is, how is washing soda prepared from sodium carbonate? So what is sodium carbonate? Sodium carbonate is Na2CO3. I told in the previous slide also, this Na2CO3 alone is just sodium carbonate. This sodium carbonate will absorb water molecules. It will absorb 10 water molecules to give Na2CO3 dot NH2O. This Na2CO3.10H2O is called as washing soda. So this is the first equation. Give the chemical equation. This is the chemical equation. And before writing the chemical equation, write in words that sodium carbonate will absorb water molecules in its surrounding. It will absorb 10 water molecules to form sodium carbonate.10H2O. This is also known as washing soda. Write the reaction and there was state the type of this salt. That is, what is this type of salt? Here sodium and carbonate have combined together to form a salt. So we will say this is a basic salt. So washing soda is a basic salt. What type of hardness of water can it remove? The applications of washing soda, it can remove permanent hardness. So answer part by part. First part of the question, write the sentence. Second part, write the chemical reaction, make sure it is balanced. Third type, what is the type of salt? Write it is a basic salt. Fourth, what type of hardness is removed? It removes permanent hardness. If you write answer all the 4 parts correctly, you will get 3 marks. This was a very recent question. It was asked in 2022. Now, the next question. This question was also asked in 2009 for 2 markers. So, let's read the question. The question says it is a compound. It is prepared by gypsum salt. So what is, we'll go back and see what did we prepare from gypsum salt? We prepared plaster of Paris. How? By heating it to 373 Kelvin. So we'll go back to this question. The question says a compound is prepared from gypsum has a property of hardening when mixed with proper quantity of water. So identify the compound. What is the compound that will be found? It is plaster of Paris, right? Like I am writing in short as POP, but please make sure you write plaster of Paris or calcium sulfate dot half H2O. Write the chemical reaction for the preparation. This reaction you have to write CaSO4.2H2O on heating with at 373 Kelvin. The temperature is very much important. We will get CaSO4 half H2O, which is plaster of Paris plus water. And the third part of the question is for what purpose is it used in hospital? It is used as a cast over fractured bones, and you can write that it is used as a cast for fractured bones, and it is helpful in treatment. With that statement, if you answer all the three parts, you will get 2 marks. So now we have solved questions on salts and we have seen some previous year questions. Let's move forward. Now let's summarize acid, bases and salts. We started this chapter with understanding what are cations, anions, metallic oxides and non-metallic oxides. Then we even differentiated between acids and bases. We saw the differences between acids and bases, how acids are burning in nature, bases are soapy in nature, they are sour in taste, they are bitter in taste. Then we saw some major examples. Always remember there are 3 mineral acids, HCl, H2SO4 and HNO3. Never forget these 3 mineral acids. So we saw acids can be classified as organic and mineral, even bases as organic and mineral. And we all just remember that all organic acids are weak acid. If they have given some example in your question paper and it is an organic acid, they are asking if it is a strong acid or a weak acid. Tell it is a weak acid, because all organic acids are weak acids. The same thing for bases also. All organic bases are weak bases. After we differentiated between acid and bases, we came to indicators. In indicators, we saw different types of indicators. Remember the color change, it is very, very important. How color change is happening in each of the case. They will ask these kind of things in your 1 markers. And if you by heart this table, if you know this table properly, acid, bases with the indicator is completely completed for you. Next, we studied about important reactions on acids reacting with metal bicarbonates and metal oxides. If in metals it is releasing hydrogen gas, how to test hydrogen gas? We studied hydrogen gas, there is a pop sound. So remember, pop sound is there, hydrogen gas is confirmed. Then we saw how to confirm carbon dioxide gas. Carbon dioxide gas turns lime water milky, so that is a confirmation for carbon dioxide gas. Next, we saw how bases react with different metals and metal oxides. And here also hydrogen gas is the same pop sound. And we saw the reaction happening. After this, we solved some previous year questions. And then we started off with salts. We saw the 4 major salts that we were studying. We saw how it is manufactured from NaCl, the common salt. From how NaCl, we are producing caustic soda, NaOH, bleaching powder, baking soda, washing soda. What are their applications? How it is very useful in our everyday life. Then we also saw about gypsum producing plaster of Paris and what are their applications. With understanding about all these salts and solving previous year questions, we have completed acid, bases and salts. So thank you for watching this video. For more such videos, subscribe to Why Thinkers.